So today it's time to write some proofs. We are going to write 2-column proofs today. You don't need to write this down. I'm just going to go over how the proofs are going to look and how they're going to work. So you're always going to be given some information. I usually call these the hints. You do not need to write this down. So you're always going to have a given and a prove. The given is your hints to help you solve the problem, and the prove, I call that your challenge. Your prove is where you need to end up. Your prove is what you're trying to achieve. So you've got your hints, and those are very useful to you, like in any board game or any game that you're playing or solving. Hints are very helpful. Same with your given. Your given statements are going to be very helpful. And then you're going to try to reach your challenge. You're going to try to get to the proof. Today we're going to do very simple ones. Nothing complicated, nothing tricky. Tomorrow we'll do some more in-depth kind of maybe proofs that you have to think a little bit deeper. So today you're going to be true mathematicians and you're going to prove, but they're going to be pretty easy. They're going to flow very nicely. All right? So you'll make your statements in the statement column, and then in the reason column, that's when you write your definitions or your theorems or your properties. Okay? Now, to me, writing a proof is a lot like writing a recipe for your favorite meal or your favorite dish. Peanut butter and jelly is not my favorite meal. This was just an example. But if you know how to cook something really well and you want to explain to someone else how to cook it, you need to tell them exactly what the quantity is. You need to tell them what the order is. You need to give them instructions. Same with proofs. If you really know that these triangles are congruent, you need to give the reader specific instructions of how they're congruent. You can't just say 2 angles match, just like you can't just say throw in the cinnamon. No, you need to tell them, oh, I need half a tablespoon of cinnamon, or segment AD is congruent to segment BD, or whatever. You need to be specific, and you need to go in a certain order. Same with recipes. You need to be specific and go in a certain order. So what you'll notice here is I have steps, but they're all mixed up. So sometimes in a proof, there's pretty much one way to start. To start this sandwich, we got to take all the things out. We got to get the bread out, jelly out of the fridge, knife from the silverware drawer. There's no way around it. You kind of have to start by getting your ingredients out. Then you want to make sure you open the lids of the peanut butter and jelly. You can't start spreading them unless the lids are open. But then you get into this middle ground. You get into this part right here where, well, it doesn't really matter if I put the jelly on or the peanut butter on first. Doesn't matter if I throw the cinnamon in first or the nutmeg in first. So you get to this part where in the middle, I can kind of change the order and it won't affect the outcome. And then at the end, you always want to end in the same way. You're going to end with eating that sandwich or eating your recipe. So you kind of start a certain way, you end a certain way, but what you do in the middle is sometimes flexible, and that's how a proof is as well. All right, so let's start with our first proof. Go ahead, oops, I did not mean to do that. In your notes, go ahead and write 2 columns. One of them should be titled statements, and the other one titled reasons, and then draw the picture. So I want 2 columns and a picture. I'll give you 10 seconds to do that. So this one I'm kind of going to lead you in, and then I'll let you try the other ones on your own. So a proof always begins with one of the given. That's how we start it. Now, I could probably start with a different step. I'll tell you later which one you could have started with. But I always start with the given because those are your hints. Those are your things that get you started. So that's what I recommend you do first. So your first statement is whatever the given is. Segment RT bisects angle QRX. And sometimes I cross it out when I've used it. So we plagiarize the given. We copied it word for word, and you are totally allowed to plagiarize the given. Now we need to say a reason, and this is the easiest reason that could exist. The reason that RT bisects QRS is because it was given to us. So easy. So you write the statement, and then if it was given to you, it doesn't bisect that because of a theorem or a definition. It bisects that angle because they gave us that information. It was one of our hints. Okay, now what you do is you go see if you're allowed to add any markings to your picture. Can we add a marking if RT bisects QRS?
Yes.
Yes, where can we add the marking?
Segment marking.
No, not segment.
Arcs.
Erase that, please. Erase that. So, if angle QRS got cut in half, then angle QRT and angle SRT are congruent. Are we okay with that? Because I heard some scary answers. So, if an angle got bisected, that means that it created two congruent angles. So, angle QRT is congruent to angle SRT. Now, why is QRT congruent to SRT? What's our reason? That wasn't given to us.
Angle bisector theorem.
Yay! Well, yeah, definition. Very good. Definition of angle, oh, I forgot my F, angle bisector. A lot of times, your reason is going to come from the previous statement. Do you notice how this reason is derived from that statement? That statement said something about angle bisector, and our reason was angle bisector. So you're going to kind of go diagonal when you feel lost and don't know what to say. Now we're kind of at a dead end. We used our angle bisector. We did whatever we could with angle bisector. So when you get to a dead end, you go to your next given. Angle 1 is congruent to angle 2, not because of a theorem, not because of a definition, but because they gave it to us. So I'm going to write given, and I'm going to go mark my picture. Angle 1 is congruent to angle 2 because of given. That's a dead end. You can't do anything else with that. So what is our next statement? Someone said it earlier.
RT is congruent to RT.
That'll work. That's the next thing we would mark if we were trying to mark this picture. That's what we would do next. We would go do this. Please don't put shared side as your reason. Shared side is never a reason. It's not a postulate or a theorem or a definition. What's the reason?
Reflexive property.
Yay! So, oops.
RT or TR?
Doesn't matter. I don't care. So, there were two theorems on your page with all the theorems and the definitions. There were really only two of them that were new. Two of them that you need to memorize. And they are the reflexive. I bet you've already memorized it because it's come up so much. I keep doing that. It's weird. The reflexive property and the right angle congruence theorem. Those were the only two that were brand new and that you kind of have to memorize and figure out when to use them, okay? The rest of them were things that we had learned. Okay, I'll add that to it, sure. There we go, three things. All right, you always end a proof with the proof. You always end a proof with the proof. So you start with the given, you end with the proof. You start with the given, you end with the proof. So triangle RTQ is congruent to triangle RTS. And what is the reason?
Angle side angle.
Perfect. I'll tell you one mistake that I see sometimes on the last reason. Since people put given first, they think that you're supposed to put prove last. But prove is not a reason, so just be careful. You end with the prove, but your reason is not prove. Your reason is, why are those triangles even congruent? They're congruent because of angle side angle. All right, go ahead and our second example, our last example. Go ahead and write down your T-chart, write statements, reasons, and draw the picture. You'll see on the homework, no, they're not all 5 steps. That just happens to be the ones in our notes. Tomorrow we'll do some that have longer amount of steps, and on your homework you'll see varied amount of steps. So we are going to start with one of our givens. angle 1 is congruent to angle 6 for no other reason except for given. Yes, they're alternate interior angles, but that's not the reason in this proof because they just gave it to us. We didn't even have to use parallel lines here. All right, I can't go any further with that, so I'm going to head on to my next given. Angle 3 is congruent to angle 4. Given. Use it. Okay, we've used all of our givens. What do you want to do next? The obvious one. What do you think?
AD is congruent to AC.
Very good. A segment is congruent to itself.
Wouldn't 2 and 5 be AC?
It doesn't say anything about 2 and 5, so I'm not going to do anything with 2 and 5. Okay? What can we say now? At step 4, we're already ready to say what?
The triangles are congruent.
Yes, we are all ready. The proof isn't even over, and we can say that the triangles are congruent. Now, you get to pick the order. I'm going to choose A, D, C, so now I have to say C, B, A. The order has to match, but you kind of get to choose the order on your own. Why are those triangles congruent? What's the reason?
ASA.
Nice. Angle, side, angle. And then if you're like, well, wait, I've already proved them congruent. What do I do now? You always end with the prove. You always end with the prove. You always end with the prove. So, segment AD is congruent to segment CB. And every time you go past proving the triangle's congruent, the reason is always the same. Why is AD congruent to BC? Why?
Because they're congruent.
Because corresponding parts of congruent triangles are congruent. Because their corresponding parts of congruent triangles are congruent. They are congruent because the triangles are guilty. They're guilty of being congruent, so now all the pieces are congruent to a corresponding piece in the other triangle.